All right, we got to profiling, which is my favorite part of this section. So in this section, I'm going to show you a performance problem I have created in this application. And then I will show you how we can detect and fix this. If you want to follow the steps I'm doing, you can download this application from the supplementary materials of this lecture. So when you extract the zip file, do an npm install and then ng serve. So this is the same application we've been working with in this section with a few minor changes. We've got this title here and a new button to change this title. Also, in the list of movies now we have 10,000 movies. I deliberately added a lot of objects to pronounce the performance problem so you can see it. And all these ones you see here are properties of each movie object. You will see that in a second. So let's go to app component. Previously, we initialized the movies field right here, but I moved that in the constructor in a loop. So we create 10,000 movie objects and push them into our array. Now each movie object used to have only one property, which was title. Now we have 10 additional properties here. So prop 1 to prop 10, and I just set their value to 1. And if we go to the template for the movie component, you can see I'm rendering all these additional properties in a span. Again, I have deliberately done this to pronounce the performance problem. So let's see what's going on here. When I click this button, change title, it's going to take several seconds until the Hello World title is updated. Let's have a look. Look, the button's still in the push state, it's blue, and we are waiting and waiting and waiting. Finally, the title is updated. So it was really slow. So when you have problems like that in your application, the first thing you need to do is profiling. So we open up Chrome Developer Tools, go to the Profiles tab, make sure the first option is selected, record JavaScript CPU profile. And now we start profiling. Record. Now we can get back here and click our button to update the title. Okay, it's taking forever, just like before. All right, done. Now back to our profiler, we stop profiling. Now in this list, make sure you have selected heavy bottom up. And then sort this list by total time in a descending order. Here we can see the total time spent for various functions in our application. A lot of what you see here is internals of Angular that we don't really need to worry about. We want to focus on the parts that are about our implementation. So, for example, we've got all these functions like zone_task.invoke, zone.runTask, and so on. These are internals of Angular and Zone.js library, so we don't have to worry about it. Now, if you scroll down, you see this log function with a total time of 6,000 milliseconds allocated to it. This is our console.log. So a lot of times we throw these console logs in the code and we have no idea that they can have a negative impact on the performance of our application. In this case, if you look at movie component, you can see we're calling console log in ng-do-check, which is called pretty frequently. So this is very dangerous. The first thing I'm going to do is to comment this out. Now log aside, let's look at other stuff happening here. So once again, we go from top of the list, look at every function. If it's about the internals of Angular, we ignore it. Otherwise, we want to take a closer look at it. So we scroll down here. The first thing that catches my eye is this function here. Underline view underline app component underline host that detect changes. Now you don't see detect changes here. So let me zoom out. Okay, hopefully you can see it now, but the font is a little bit too small. So app component host detect changes. And the total time for this function is about 8,000 milliseconds. So this tells me that the view for app component has a performance problem. All right, let's go to app.component.html. What do we have here? We have a binding expression to render the title, and we have a reference to the movies component. Now let's take a look at the template for the movies component. So movies.html. Again, here we have a reference to another component, the movie component. So back in app.component.html, basically we have a subtree here. We have this movies component, which includes 10,000 movie component instances. And this is exactly the source of our problem. Why do we have to go through all this change detection when we are only updating the title of app component? We haven't modified anything about movies. But as I explained before, the default change detection strategy looks at the template for every component in our component tree, looks at all these binding expressions, gets all the properties used there, and compares their old value with the new value. We don't want all this to happen when we are only changing the title of the app component. So I believe we can solve this problem by using the unpush strategy on the movies component. This way, if the input to this component, in this case, this movies object, is not modified, if it's still the same reference, Angular is not going to run change detection on this component and all its children, which include 10,000 movie components. So let's go to the movies component, movies.ts. You can see the change detection is set to default. So whether we had this line or not, it didn't make a difference. I'm going to change this to unpush. Now we should make sure that the movies object that we pass to this component is an immutable object. So change detection works properly. So we go back to app component. Here's our movies object, which is just a plain array. I'm going to use an immutable list from immutable library. So instead of pushing these objects directly into this movies field, I'm going to push them into this temporary array I've declared here. Now, at the end of this constructor, we can set this movies field to a list and initialize it with this movies array. We have a compilation error because the type of this movies is a plain JavaScript array. So I'm going to remove this. Now to clarify something, earlier in this section, when we were working with this click handler, we used the unpush strategy on the movie component. But in this application that I have attached to this lecture, I have removed the unpush strategy on the movie component. So I was assuming that all components are using the default change detection strategy. In this application, because the source of the issue is on the change detection of this movies component, I only applied the unpush strategy on this component itself, not any of its children, not the movie component. That's not really required. All right, now with these simple changes, let's test the application again. So I'm going to click this button and the title is updated immediately. See the difference? Previously, it took several seconds. Now let's go back to Chrome Developer Tools. I'm going to do another profiling session. So record, back here, click the button and stop the profiling session. Now let's compare the result. This time I'm going to sort by functions. Now in this list, let's scroll down. We want to look at functions that start with underline view. So here we have underline view, underline app component. We only have two functions that match this pattern. The full name of this function, as you saw earlier, is underline view, underline app component dot detect changes. Note the total time spent on this function, 8 milliseconds. This is after the optimization. Now let's go back to our first profile, find the same function, and look at the total time. So profile 1, once again, we're going to sort by function. Scroll down. Look, we've got so many functions that match that pattern. Underline view, underline app component, underline view, underline movie component, and underline view, underline movies component. So you can see our change detection is going a lot deeper in our component tree. It's not just at the app component level. Now that aside, look at the total time spent on change detection in app component. It's almost 8,000 milliseconds. And we reduced that to how many milliseconds? 8 milliseconds. So in your applications, if you have performance problems that are related to detecting changes, this is how you find and fix them. Now, one last thing before we finish this lecture. In this lecture, I started by looking at the template for app component. I noticed that here we're referencing the movies component, Then I had to look at the template for movies component and see if we're using other components there. You can imagine this can be tedious and complex in a larger real-world application. So let me show you a tool that helps you visualize your component tree. And this is very useful when you want to decide where to apply the unpush strategy. So in Google, search for Augury Chrome extension. This is a great tool for debugging Angular apps built by Wrangle.io. So simply add this to your Chrome, and once you restart it, you get a new tab in Chrome Developer Tools. So back here, when I open up the Chrome Developer Tools, you'll see I have a new tab here, Augury. Now here on the left, we can see the component tree. So we've got app component on the top. Under that, we've got movies component and 10,000 movie components. Now, there is a lot more to Augury, and there is not enough time for me to cover it in this lecture, but hopefully I will find a place in the course where I can show you other useful features of this great plugin. And this brings us to the end of this section. I hope you enjoyed this section, and thank you for watching.